Hi, this is Steve with iFLOW and welcome to our video series. In this segment we're going to be looking at why iFLOW air handlers versus other air handlers. So it seems in the market many consider all air handlers alike. It's just a coil with a blower and a box, and as a result there's really not much that would differentiate it. So I'm going to ask you this question. If you paired an air handler with any heat source, the combined efficiency when space heating would likely be close to the efficiency of the heat source. So for example, if I paired my air handler with a 95% AFUE boiler, the heating performance, combined performance would likely be 95, maybe 94, maybe 90, so it's somewhere in that range. Or if I paired my air handler with a tankless water heater that has a UEF of 0.93 or 0.95, that my combined heating performance should be 90%, should be condensing, should get some very good efficiency. Would you think that's true or false? What are your thoughts? Intuitively, perhaps, you could say, yeah, it makes sense. It should probably work that way, but actually the results are showing that it's quite false. So there is a CSA standard called CSA P9-11. It is a standard that tests the performance of combined systems. So when you take any heat source and you pair it with any air handler, you will get a combined rating. These results are listed in Canada. It's used quite significantly, both nationally and across each of the provinces for rebates and for building code purposes. The results are listed on the Government of Canada's Natural Resources site, so that would be the equivalent, let's say, of the U.S. Department of Energy. Here is the link to the website. It is all public information, so I'm not talking out of school, out of class. Really, it's public information. It's there for consumers to be able to reference so that they can compare the systems that they are going to have installed in their homes. So you can download all of the results, so the 73 results, or you can go ahead and put in some criteria. But you see the range here, 0.72 to 0.98. It shows you that there is some significant variability from, let's say, worst result to best result, from 72 to 98 for the systems that have been tested so far. I'm going to look at a snapshot of some of those results, and again, I'm not trying to pick on or to degrade or to bash any of our competitors. What I want to show here with this comparison, and again, this is all public information, anybody in the public can go to that website and download all of these results. So all I want to show and demonstrate with this slide is that there is some significant variance even when using the same heat source, and even if that heat source is a high performing heat source, that the heating side of that can be very different. So for example, let's look at this Rinnai unit. So this is the Rinnai Sensei. This is their most recent model, the Rinnai RU160IN. It was tested with two air handlers on this performance, or this comparison. The high velocity ESP system, their HEP50 with the Grundfos 1558, and they scored 0.72. I then take the same heat source, the Rinnai RU160, the same Rinnai Sensei model. I tested with the Aspen air handler, and the Aspen model is the AFLM, and they tested with the Taco 008 pump, and it scored a 0.73. Now let's look at iFLOW. So we tested with that same Rinnai RU160IN. We tested it with our 18,000 model with the same 1558 as high velocity, and we scored a 0.94. So 0.72, 0.73 compared to a 0.94 using the exact same heat source, the Rinnai Sensei RU160IN. It just shows you there is some significant variability between like 72 and 94. You're talking about low efficiency versus condensing efficiency. That is the range, that's the technology difference between the air handlers in the market. So no, they are not all built the same, and no, to our question earlier, that just by using a heat source that has a UEF of 93 does not necessarily mean you are going to get heating at a 0.93 at all. Actually, your performance can be much, much lower than that. So let's look at another example. So here we're switching to the MP180A. So now we switch to the Navion unit. Again, High Velocity is testing it with their Z70 and their Z50. And they got an 86 on both of them, 0.86 on both of them. Oh, that should be on the upper line. But we tested also with that MP188, with the iFLOW, and with our 16-inch unit, and we scored a 0.98. So now you're comparing a 0.86 to a 0.98. Well, that's the difference between mid-condensing, mid-efficiency, and high efficiency. If you expect to pay the same for a mid-efficiency furnace as you would for a high-efficiency furnace with full modulation, you're confusing yourself. And this is the same on the air handler side. An 86 is not a 98% result, but we at iFLOW are able to differentiate. So all I want to do is show you that there is some variance here. And lastly, let's look at some Rheem test results. So Rheem tested their the CRTGH95DV, which is their condensing Rheem tankless gas water heater at 95% direct vent with LP or natural gas. So they tested the same heat source 3 times with 3 different air handlers that they had, and they scored 80, 80, and then a 0.82 was their highest result. So again, this is Rheem as a manufacturer testing their own 95% tankless with their own air handler. So same company, same, all made by the same manufacturer, and only scored 80%. So if you think as a contractor or as a wholesaler, you're going to be able to take a heat source and then pair it with any air handler and get decent results, unfortunately the answer is false. It's not going to happen, and that's what these test results are showing, and that is why the CSA P9 standard was developed, to be able to compare these systems. Anything that's not tested here, so if you look at if you're looking for a manufacturer and they haven't tested, you have to question, why haven't they tested? Do they not want any of the rebates? Do they not want to get any of the builder points called out in the building codes? Or is it just that they know that the results will not be anywhere near where they need it to be, so they'd rather not test, rather not spend the money, rather not publish the results, rather than actually test them and have them available. So anyway, I just wanted to go through that. That's publicly available information. There are a number of different test results. You can go on, reference the website, and you can test for yourself, see for yourself. GTI is out of Chicago, and they actually did a report where they looked at combi systems and what makes a great combi system or a better performing combi system. So let's take a look at what their results, or what they came to conclude. So from their report, it said advanced forced air systems can achieve exceptionally high space heating performance if you have these following 6 attributes. Number 1, tankless water heater that condenses even with a return water temperature of greater than 120, which means if you've got a great condensing heat exchanger and that you're able to, even at a higher return water temperature, still condense at a significant rate, you're going to have a great performing system. And part and parcel of that, you need a fully modulating burner to make that happen. Second point that they recognized in their report, you need to be able to do 2 temperatures. If you can do your domestic water temperature as 1 set point, and then have a heating set point, and a heating set point even better, that will increase or decrease, like the outdoor reset curve on a boiler. If you have that capability, you'll have great results. Number 3, delta T across the heat exchanger coil. If you have an onboard strategy to maximize the delta T across the across the hydronic coil, you will likely get very good heating performance. Number 4, preheat. If you have some way of stopping the blower, like on a call for heat, stop the blower, prevent it from running until your hydronic coil is sufficiently warm enough to deliver that warm air, you will get very good results. And the converse of that, at the end of a heating call, right, when your thermostat is satisfied, the room is up to temperature, the heating call goes away, you still have some heat left in your hydronic coil, you still have some heat left over in your heat source, whether it's your boiler, whether it's your combi boiler, whether it's your water heater. So you want to be able to pull that heat, the residual heat out of the heat source, bring it into the air handler, so keep the blower running to deliver that heat into the space so that we're maximizing the efficiency, maximizing the amount of heat that goes into the space. If you do that, you'll have great heating or better space heating performance. And then 6, short cycling. If you have a strategy to minimize the short cycling of your heat source, you will also get better results. Why? Because you're preventing it from cycling. It's going to have better efficiency. So these are the six performance attributes that they identified that would make a premier combination system. So then they went out and they tested some of those. Based on those metrics, they tested some of the combinations. So this is from their report, and this I quote. And this, by the way, is also public information. So again, we're not talking out of class. And I quote, it says, iFLOW manufactures the only air handler that GTI has identified with all of the 6 key attributes above. So then this table 1 shows the attributes and shortfalls for the different air handlers that GTI has assessed. Some air handlers did not have hydronic coils designed to generate enough delta T to induce tankless water heating condensing. So you didn't get full condensing. Why? Pardon me. Typically because your coil only has 2 rows or 3 rows. It's not sufficient enough to be able to extract that heat to lower your return water temperature to enable the heat source to fully condense. So that's what they're referencing here. So let's look at the results. So you have some metrics here. You have the coil, the delta T across the coil, right? So that delta T across the coil will basically induce condensing or not. The leaving air temperature, so they want a leaving air temperature that is not sufficiently low, that is similar to what a furnace would put out. Do you have the preheat controls? Do you have the heat flush controls? And do you have an outdoor temperature sensor that helps you adjust the heating set point? So again, iFLOW is the only one that had all 6. So again, we ranked number 1. We are happy with those results. We appreciate the work that GTI has done on this. But let's look at some of the other manufacturers. So we have NTI with the GF200 that scored well. We have the Bosch Red Zone. Rheem is up there. First company had 1 unit, the HBQB, that was sufficient across the delta T in terms of getting condensing. But then leaving air temperature was a little low. What does that mean? Well, if I have to set the heat source, so the water coming into my air handler, the temperature coming into my air handler, if I have to set that low enough or low enough to then take some heat off to send that return water back to the heat source so it will condense, then I am getting the condensing from the heat source, but I'm not getting the air supply temperature anywhere that's needed, or it'll be lower than 100 degrees. So the air delivery will be quite low, the air supply temperature. But let's look. We've got Ecologics. We've got all first company except for this one model. We've got Air Magic Pack, Air Mortex, Red Zone, Thermopride Williams. So again, these coils were insufficient to get condensing. What does that mean? Probably a 2-row coil, maybe a 3-row coil, maybe a small coil, not sufficient enough to get a good delta T across it. As such, you're not getting condensing. So for these coils, these remaining coils that were sufficient in terms of getting condensing, now they're looking at the leaving air temperature. Okay, so you got some condensing, now let's look at the delivery temperature. And that's where they were referencing, if you have a tankless water heater or boiler that can condense at a return water temperature even as high or greater than 120, you're going to get great results. And that's what they're referencing here, because the return water temperature is indicative of what your air supply temperature will be in most cases. So if your return temperature is 120, your air temperature is going to be 120, 130, somewhere in that range. But if your return water temperature is lower than that, meaning your entering water temperature was lower, then your air supply temperature is going to be lower, which means the homeowner might put their hand on the register and say, hey, that's not hot, that's not the heat I'm looking for, or not what they're used to based on the furnace performance. So that's what the leaving air temperature is all about. Next is the preheat controls, yes or no. Heat flush controls, yes or no. Not many had those heat flush controls. That's going to give you some extra points. And then your outdoor air temperature reset curve. Most of the boilers will have that. Navien has that. iFLOW has that. So, taking the results of the P9, taking the results of the GTI study and combining those two together, they don't really pinpoint exactly what features of each, the heat source and the air handler, they don't particularly identify which features will make that combination system work well together. So we have taken a stab at identifying or qualifying based on common features found in boilers, combi boilers, tankless water heaters that will allow us to get those higher performing combi systems. So for example, on the heating side, the heat source side, right, can we use any heat source? And the answer is no, right? Some will perform better than others. So let me give you an idea of which systems will perform best. So for example, a heat pump water heater will perform very, very well, 3 or 4 COPs of 3 or 4. And if it has a UEF of 3 or greater, that would be a great solution. Tankless water heater with a UEF of greater than or equal to 0.95, with a turn down ratio of 10:1, ultra low NOx, and with an outdoor temperature sensor and the ability to adjust the heating temperature. If you have those, you'll perform very well. For example, the Navien with the H2 Air Kit will give you some additional capability. Boilers, if you have a combi boiler with an AFUE of 95 or greater, with a turn down ratio of 10:1, with an outdoor sensor, which most boilers have, you will have a great performing system. If you have a combi boiler, a boiler with an input of greater than 60,000 BTUs and an AFUE of greater than 95 with a turn down ratio of 10:1, with again ultra low NOx and the outdoor temperature sensor, you will get very good results. If you have a smaller boiler, let's say with an input of 60,000 BTUs or less, and an AFUE of 95 or greater, with a turn down of 7:1 with that outdoor sensor, you will have a good performing system. So those are the tier 1, let's say tier 1, or they're the best performers. Those are the features that they will have. Negative pressure gas valve with a fully modulating burner system is important as well. Tier 2. Tier 2 would be, let's say, a heat pump with a UEF of 2 or greater. A tankless water heater with a UEF of 93 or greater with a turn down of 8:1 or greater. Again, ultra low NOx with that outdoor temperature sensor. Boilers with less than or equal to 60,000 BTUs, an AFUE of 93 or greater, with a turn down of 5:1. Those would be a tier 2 solution. A tier 3 solution, an electric water heater with a 0.93 UEF, a tankless water heater with a 0.93 UEF and a turn down of 8:1, without the outdoor temperature sensor though. If you don't have that capability of doing those two temperatures, it's really going to be difficult for you to score in that higher range. We're looking at a tank type water heater. This is an Energy Star water heater on the gas side with a UEF of 0.78. So this is for a gas tank type water heater. So that kind of identifies the differences on the heat source side. Now let's look at the air handlers. So can I use any air handler? And the answer is again no. There are metrics that will differentiate Tier 1, Tier 2, Tier 3. So let's look at the best performers. So the Tier 1. So in the Tier 1, if you have a constant CFM ECM blower, so not all ECMs are made the same. The fully modulating ECM is the constant CFM blower, or the Dextar, and whatever like the Gentech Eon, or any similar competitor models to the Gentech Eon. You will need a 4-row coil, a minimum of 4 rows. If you have a 4 or 5-row coil, that will likely get you the delta T. That's going to make a better performing system. If you have integrated pump control, where you're able to manipulate the GPM rate through the coil, through the heat source, that's going to assist in performing, giving you better performance. As GTI mentioned, if you have a strategy, an onboard strategy to manage the delta T across the coil, so to adjust whatever parameters you need, adjust your blower speed, adjust your pump speed, whatever that may be, and that can depend on whatever manufacturer you're using. But if they have some delta T control, you'll get a good performing system. Again, you have that heat flush, that preheat and heat flush function. Those are really a function of adjustable blower on and blower off delay sequences. So again, if you have some strategy to do that, you'll do well. Let's look at Tier 2. Tier 2 would be a constant torque ECM. So again, not all ECMs are made the same. The constant CFM ECM is your fully modulating ECM. Your constant torque ECM gives you 5 settable tabs. So you get 5 settable tab speeds on that. So it's not fully modulating, it's stepped, right? It's stepped in 5 steps. And that's similar to the Gentech X13 blower, or any similar competitor model. That's going to be a Tier 2 blower solution. Let's say a minimum of 3 rows, right? So again, it's not as good as the 4 or 5 rows, but it's not going to perform as bad as a 2 row. So 3 rows kind of in the middle. That's why it's a Tier 2 solution. If you have a 3-speed circulator so that you can adjust the speeds, that'll help you dial in kind of it'll improve the efficiency of the system. Again, you have an adjustable blower on and off. Here you have a fixed air handler blower on and off delay, but nonetheless you have it. It's fixed, so it's not going to work as well as an adjustable, but it's going to work nonetheless. Not as great, that's why it's a Tier 2 solution. And let's go to the Tier 3 now. So Tier 3, simple PSE motor, no modulation, it comes on, it runs at 1 speed. You have a 2-row coil. Again, you're not getting the delta T likely if you're running at 160 degrees, because that's what your spec requires the entering water temperature to be to hit the certain BTU level that you've identified in your spec. Then you may not get any condensing, right? If you got a 2-row coil, you're likely going to be a 15 degree, 20 degree delta T across the coil. If I'm operating at 160 to get the BTUs, that means I'm coming back at 140 into the heat source, or 145. I'm not condensing, right? So that's why you are Tier 3 solution. Single speed hydronic circulator, right? It's just going to run at 1 speed, that's it. So single speed blower, single speed pump, 2-row coil, not going to perform very well on a combi system, even if you're paired with a heat source that has a 95% efficiency. You're not going to be able to get that delivery on the heat side. So again, Tier 1, Tier 2, Tier 3. So let's mix and match that matrix now. So what we've done here is we've taken our Tier 1, Tier 2, Tier 3 water-based heat sources, your boiler, your tankless, your combi boiler, and then we've paired that with the air handler, Tier 1, Tier 2, Tier 3. And let's look at what we get. So when we pair a tier 1 water heater with a tier 1 air handler, we're likely to get results in the 92 to 98 range on the heating side. So great performance. Tier 2 to tier 2, we're likely in that 80 to 85 range. So again, we're low mid efficiency units. And then tier 3 to tier 3, now we're down into that 66 to 72% range. So again, performance is not where you want it to be, given that you're going to be running your heating in the colder areas of North America anyway. You're going to be running it for 4, 5, 6 months of the year. You don't want it performing at that 70% range. So again, this is the matrix. This is kind of how it works together. And again, this is compiled from the results from the P9 in combination with the GTI metrics to kind of give you some idea what features will give you what results when they're installed in the field. So again, if you want some of this information, just email me. I'll give you my email contact information later. But just email me and I'll send you this information. So let's look at performance results. Again, on the iFLOW side, both in Canada and the US. So this is on the US side. This is GTI report. We're looking at 95% furnace in red. So that red line is the performance of the 95% furnace, and then in the orange we have the performance of the iFLOW with the Navien. So again, this is on a range, the 60,000 BTU furnace, 2-stage, looking at the modulation range. We need most of the heat in this range because most of it is in the shoulder season. But you see, because we can modulate a little better, you see that area in green is the performance improvement of the iFLOW Navien combination system compared to 95%. This is a field study result from Enbridge. So again, Enbridge is the gas utility in Ontario. They looked at 3 different locations. They measured the iFLOW with a 97 EF tankless water heater and compared it to a 95% furnace as their baseline. And we scored almost a 19% improvement in efficiency. So that's 95% or 19% less gas consumed. That's less emissions. That's better performance, no question. So that was at their Hull and Landing test site. Pickering, another test site. Again, same combination, the iFLOW with the 0.97. We scored 11.3% better than their 95% baseline furnace. In the third field study, this is at Breslau, they switched up a bit. They used the iFLOW, but they paired it with a combi boiler, 95% AFUE combi boiler, and in that case we came out at 10.4% better than the 95% furnace. So if we average the 3 of those, we're looking at an average improvement of 13.5%. So again, these are real field studies. This isn't iFLOW data. This is data coming from the utilities themselves in terms of savings. So the P9 standard, I just want to point out how they get to the results. So the results, they take a heating weighted efficiency and a water heating efficiency, and then they combine them. But on the heating side, they're using 3 different weightings. So you run your air handler, your combi system, at 100%. So if I've got a 60,000 BTU system, I will run that at 60%, at 60,000 BTUs. They're going to measure the efficiency of the system, and that weights for only 10% of your score. Only 10, because really, when's it going to be running at 100%? It's going to be running at 100% at design load, middle of January, middle of February, coldest day of the year. That's when you may need maximum. Doesn't happen very often. They then measure at 40%. So again, if I use my 60,000 BTU air handler or combi system example, now I'm running at 40% or 24,000 BTUs. So now at 24,000 BTUs, I measure the efficiency, and that weighs for 60% of my score. So they're giving a much more heavy or much heavier weighting for operating at 40%, because that's more reflective of what you'll need in, November, December, March, for example, the shoulder seasons. And then they measure the efficiency down to 15%. So again, if I'm using my 60,000 BTU combi system as an example, now I'm testing down at 9,000 BTUs. So I'm cycling the heat source a little bit, but I'm measuring my efficiency nonetheless. So I'm testing down at this low range, and it equates to 30% of my score. So if you see here, 90% of my total score on this CSA P9 standard comes from operating at 40% and below. What that's saying is that, hey, we recognize that the majority of the operation is going to be in the shoulder season. It's going to be a cold September night, a cold October night where I need heating just at night. I've got some solar gain during the day, so it warms up. It's going to be fine. I don't need heating during the day. I need it at night. And then as I move into November, okay, now it's getting a little colder. I get into December, January, February. Okay, now in winter months. But then I get into March and April and I start to warm up again and I don't need my maximum anymore. So it's saying, hey, we realize that the efficiencies at these lower ratings are going to be representative of how the system will likely operate in the field, so we're going to give it a much higher weighting. So they come up with the combined space heating weighted average, they pair it with the water heating results, and you get your TPF, or your combined efficiency. We're fairly happy at iFLOW with the results we've got. We've scored 4 of the top 6 rankings for those listed on the Enercan website. We scored the highest combined efficiency of any system tested to date. We scored a 0.98, and we did that with the Navien tankless water heater. We also scored the highest TPF or efficiency score of any air handler manufacturer that is tested with the Rinnai Sensei system, and we scored a 0.94 using their RU160IN. So again, we scored the highest of any system tested at 98 with the Navien, and then we scored the highest of any manufacturer that's tested with the Rinnai. So when we're testing with the tankless water heaters, whether Navien or Rinnai, the leaders on the tankless side, we at iFLOW are lucky enough to have scored the highest with both of those. And again, 4 of the top 6 rankings. So we're happy with those results. We just wanted to, in this segment, identify what makes an air handler performance good, better, or best, and what features, what technical features can combine to make those systems, and basically to show that all systems aren't made the same. As I said earlier, we don't want to bash our competitors, we don't want to bash the other air handlers in the market, but by the same token, we definitely want to point out that we at iFLOW are doing something different. We are using 4 and 5 row coils. We are using the best ECM blower in the market. We are using some fairly advanced control strategies to measure and to ensure that we're getting the full condensing from the heat source, and we're maximizing the delta T across the coil. We're able to modulate the blower, we're able to modulate the pump flow speed, we're able to, with all of our sensors, we're able to know exactly what our delta T across the water side is across the coil, the delta T across the air side, so that we can then adjust automatically to be able to deliver the best performance. We have an outdoor sensor that we want everyone to hook up, because it'll allow us to, again, target the delivery in the shoulder seasons versus the middle of January when you need it. So we've incorporated all of these features into the iFLOW, differentiating it from the other air handlers in the market, and we just wanted to point that out because as I opened with, it seems that many in the field just think an air handler is an air handler, and they're all the same. They're just a blower in a box, and we wanted to show here with the performance results that it's not just the blower in a box, and they're not all made the same. So I thank you for your time. Appreciate your interest in this. Again, you can go to the Enercan website and search for these for yourself if you have any questions. Again, the GTI report is publicly available as well. Should you have any questions, please reach out to Toll free 1-800-985-9227. I'm at extension 102. Or send me an email, steve.bagshaw at iFLOW Again, thank you for your time. We appreciate it. We'll see you in the next video series. Thank you.